Hey everyone, and welcome back to another video. Today we are going to be learning about frame of reference and vectors. Okay, so without further ado, let's get started. So hopefully you guys kind of understood what was happening in that Mythbusters video, but if you didn't, let me go over it really quickly. So here we have a truck, okay, and it's going to be driving down at some speed. Let's even say he's going 10 meters per second, why not? Okay, and he's going in this direction. All right, at that same time, right as it passes our little observer, and I'll call him observer, right at that time, a ball is going to be shot, right, and it is going to be shot at that same speed of 10 meters per second of however fast that truck is going. So this ball is going to be shot 10 meters per second in that direction. So now the question was, what is it going to look like when this ball, to the observer of this ball, right? And so before we can even answer that, let's even go over a couple terms before we even tackle this type of problem, okay? So without further ado, let's get started. All right, so what we're going to do is we are going to be moving on to frame of reference. So what is frame of reference? Well, frame of reference is just some form of access point that we need to create in order to make certain measurements. Okay, that just doesn't really make too much sense, right? But let me kind of explain this to you. So right now, I am going to have this ball, right? And I'm gonna put this ball into this car. And what I'm gonna do is, I'm just gonna roll this car down. Now, from my perspective, my very own perspective, me observing the car from right here, how fast is my ball going once I push the car? You might think, oh, that's okay, I understand. Like, the ball is going the same speed as the car, right? From my perspective, which makes sense, okay? And so now I want to ask you this question. Let me do the exact same question, but let's say I want to know how fast is this ball going from only the perspective of this car. So not my perspective. How fast is the ball going in this car once I push it? Well, if you kind of think about it, the ball is moving at the same speed of the car. So if that's the case, then the ball shouldn't be moving at all. Which is correct, right? The ball shouldn't be moving at all from the car's perspective. This is the equivalence of you driving down the freeway, right? And you are actually driving the same speed as the car itself, right? If you're driving 60 miles per hour down the freeway, you're going 60 miles per hour. Do you feel like you're going 60 miles per hour? Not really. From your perspective inside the car, you're actually feeling motionless, like you're not moving at all. Only from your perspective in the car. But from an outside perspective, we can see that you're driving down at a certain speed. And I hope this kind of makes sense a little bit of what frame of reference looks like. So now what I'm going to do is, I'm going to take this same ball, and I'm going to put it in this plunger. Okay, and so now what I'm going to do is, I'm going to move this car, and once I release this string, the plunger is going to shoot up, and it's going to come back down. Okay, just like so. Right, so we could see that the ball is just going to shoot up and down. And so now what I'm going to do is, let's add a little bit of a dimension to it. What do you think is going to happen to the ball when this car is going to be moving? Okay? Think about the shape of what the ball will look like from your perspective, and think about the shape of the ball from this cart's perspective. All right, let's see it. All right, so from your perspective, what did the ball look like in its entire trajectory as the car was moving? Well, we can see that the ball kind of made some form of upside down U, right? Or a parabola, right? And so that makes sense to us because the ball was just moving kind of like this throughout its entire perspective, or from your perspective. Now, what about from the cart's perspective? what do you think it would look like if we placed a camera on this car? Well, it would look like the ball is just shooting up and then back down, right? And then so that is going to be from its frame of reference. And so I hope this kind of makes sense with you, and hopefully this will help you with your questions on the Mythbuster video. So, back to me. All right, so after we get a good understanding of frame of reference and those definitions and what it really is, now we can actually kind of develop a question for this entire example. So our question would in this case be, when firing a soccer ball in the opposite direction on a moving truck, what would it look like from the frame of reference of the observer? So right now, the truck is moving in that direction, the ball is being shot in that direction. We want to see what this ball is going to look like from the perspective of my observer right now. Okay, and so before we can even go further into that, we do need to learn a little bit about vectors. Okay. All right, so I hope frame of reference kind of made sense with you. And so now what we're going to do is we're going to be moving on to scalars and vectors. So before we even go into that, let's talk about what is the difference between what speed and velocity is. Well, we could see these terms and we're like, oh, they're exactly the same. Well, not exactly, okay? So first of all, think about driving down the freeway, right? And then you're driving across a speed limit sign. Well, that just tells us how fast we can't go over that number of how fast we're going, right? It's just a number, okay? So why aren't there any velocity signs? Well, what is velocity? Well, velocity is very similar to speed, but it also has to deal with some form of given direction. For example, I could have my car and say, okay, I'm looking at it, it's going 3 meters per, not 3 meters, let's say 1 meter per second, right? I could see it's going 1 meter per second of some sort. But now, how would I determine what a velocity is? Well, I could still push it at 1 meter per second, but I could say it's going 1 meter per second towards my box. So I gave it a value of how fast it's going as well as a direction. And that's velocity. So now that we have a good understanding of speed and velocity, and we can now determine the difference between what a scalar is and a vector is, now what we're going to do is I'm just going to kind of show you the definition between those two. So once again, scalars are just determining what that magnitude is. Okay, it's just a number, and so it could be explained as either how far something is, so a certain distance, how fast something is going, time, because time is just a number and it's always going up, or the mass of an object, because mass never changes, it's just a number. All right, and so with that, we also need to look at what a vector is. And a vector is just the magnitude as well as the direction of an object. So once again, in that past example with our cart, I pushed that cart in a certain direction and it got a given speed. So therefore, it has speed, but also has some form of direction as well. And that's what constitutes it as a vector. So other examples are going to be displacement, which is honestly the vector version of distance. We talked about velocity, and then lastly, weight. Now, why is weight a vector? Well, remember, weight has to deal with how much mass we have, as well as how acceleration of gravity is pulling down on us. Because acceleration is pulling down on us, acceleration therefore has to be a vector, which means weight also has to be a vector as well. Okay? And so, a couple things with vectors and their components. Typically, this is the way that we would write what it would look like. So right here, I'm going to have a little dot, and I call that the tail. Okay, the start of our dot is the tail, and then we draw a line with an arrow. The arrow is called the head, and typically we have a number on top representing how much of it has, just like this right here. Okay, so now what I'm going to do is I'm going to move on to vector addition. Okay, so let's move to right here. So with vector addition, the cool thing with vectors is that you can add them or subtract them just by putting two vectors together. And that's the reason why we kind of use vectors so much. It's because we can manipulate them to determine what we want to find. So in this case, let's say I have a vector that is 10 in that direction and a vector that's 5 in that direction. If you add those two vectors up together, you're going to get a resulting vector of 15. Now these are just arbitrary numbers, but once again, if we kind of think about like a scenario, let's say I was running down the street, right? And I was running, say, at 10 meters per second. That's pretty fast, but 10 meters per second, I was running down the street, and then a gust of wind of 5 meters per second comes behind me. How fast am I going to be going at that point? Because the wind is helping me in that direction. So that is kind of a way we could kind of see vectors all around us. And that's just only one example. Now, this is vector addition, right? So we have two vectors adding in that direction, but what happens if a vector is adding in the opposite direction? Well, we can see right here, if I have a vector of 10 going to the right and a vector of 5 going to the left, we would still add it. So from head to tail, we would always align them up, and that's the way we add vectors. You would align head to tail, and then we would have a resulting vector of only 5. So we're kind of subtracting it because we're determining what direction it's actually be going into. So once again, I really hope this helps with vector addition. So we found out that the ball just drops to the ground from our observer's frame of reference. Once again, why does this happen? Well, as this car, or as the truck was moving 10 meters per second to the left, the ball, while in the cannon, was also moving 10 meters per second to the left, but the cannon shoots the ball in that direction with enough force that it negates that activity. Therefore, according to the observer's perspective, the ball just falls directly to the ground. Now, thank you guys so much for watching this video, and I really hope this helps with your understanding of frame of reference and vectors. So I'll see everybody later.